Okay, the last part of the problem says, given this modified circuit, where we've got our impedance of the source and our load impedance, find the reactive and complex power absorbed by the load. The standard way to find any kind of power, the answer to any power question, is to find the voltage across it and the current through it. So we want to find this voltage across the load, and we want to find the current through the load. So the voltage across the load is going to be, this is just a voltage divider. It's going to be 120 volts times the impedance across which we want to find over the whole impedance. And here the plus J80 and the minus J80 cancel, as they always will when we've got maximum power transfer, because for maximum power transfer, we want to have the entire thing looking resistive. And that will give us 60 minus J60 volts RMS. And that's our first partial solution. Then we want to find the current. And the current's going to be equal to the voltage, and that's in volts RMS, divided by the total load impedance. And that will be 80 plus J80 plus 80 minus J80. And as before, the 80s cancel. And so that just gives us 120. This would be in ohms. And so that gives us 120 over 160, which is the same thing as 3/4. And VRMS divided by ohms gives you amps RMS. And there's our second partial answer. So now we can solve our entire problem by saying that the complex power phasor, which is always equal to the RMS power phasor multiplied by the complex conjugate of the current power phasor, which will be equal to 60 minus J60 times. So for a real number, the complex conjugate is just the same thing. There's no imaginary part to take the negative of. So that's going to be equal to 45 minus J45, and the units are volt amps for apparent power. And that's the answer to the first question. This is the complex power absorbed by the load. And then to find the reactive power is symbolized by Q, and that's just the imaginary part of our complex power phasor. So that would be equal to minus, now it's the imaginary part, so we don't include the imaginary number, just minus 45, and that would be volt amps reactive. So that's the reactive power absorbed by the load. Intuitively, it's that much power that's being shuffled back and forth between those transmission lines. And although it didn't ask it, it'd be pretty easy to find out what the average power is from your load. It would just be equal to the real part of your complex power phasor. So that would be equal to 45 watts. And that's the real or average power absorbed by the load. And that completes the problem.